Welcome to The Explainer. Today we're talking about something huge in AI video, a breakthrough that just completely blew past the old time limits. Let's get right into it.
So for the longest time, even the most powerful AI video models, the big ones like Sora, were just stuck. They could make these incredible, mind-blowing clips, but they always hit this hard wall at around 5 seconds. It totally locked away any chance for real storytelling. So you gotta wonder, right? Why 5 seconds? What was it about that specific time limit that was so darn hard for AI to get past? Well, it all comes down to how these models actually build a video from the ground up.
Okay, so most of these models use this method called autoregressive generation. The best way to picture it is it's like telling a story, one single word at a time. The AI makes the first few frames, then it looks at what it just made to guess the next few, and on it goes, piece by tiny piece.
But, and this is a huge but, this step-by-step process has a major flaw hiding inside. If the AI makes even the tiniest little mistake in one piece, I'm talking a slight blur, a weird shadow, anything, that mistake gets baked right into the foundation for the next piece. And then those mistakes just start to snowball. Fast.
All right, let's really dig into this problem. The researchers have a name for it: error accumulation. And honestly, it's the single biggest reason AI videos would just completely fall apart after a handful of seconds.
And this shows you exactly what happens. Look, at 5 seconds, the video starts out looking fantastic, right? Perfect. But as those tiny errors start piling up, by 25 seconds, it's already getting blurry and kind of weird. Fast forward to 50 seconds, and the scene might just freeze up entirely. And by 75 seconds, it's just a total chaotic mess. Unusable.
This whole error accumulation thing usually ends in one of two ways, and they're both pretty bad. The first one is called overexposure. The video just gets brighter and brighter and more washed out until, poof, it's a white screen. The other one is motion collapse, which is exactly what it sounds like. All the movement just stops, and your video becomes a frozen, static picture.
So, how on earth did researchers finally crack this thing? Well, they came up with this really clever new training method. It's called self-forcing ++, and the whole idea is based on something we all understand: a teacher and a student.
Here's the setup. It's pretty simple. You've got a teacher AI. Now this AI is an expert at just one thing: making those perfect, high-quality 5-second videos. Then you've got the student AI. Its whole goal is to figure out how to make videos that are way longer than that.
Okay, now this is the key insight, and it's pretty cool. Even though the teacher model can't make a long video on its own, it's been trained on so much data that it knows exactly what a good short video clip is supposed to look like. It might not be a long-form director, but it is a fantastic critic.
So check out this training loop. This is where the magic happens. First, the student AI is actually told to go ahead and make a long, flawed video. The exact kind that would normally break. Then, the teacher steps in. It doesn't look at the whole messy thing. Instead, it just samples random 5-second chunks and basically acts like a coach, showing the student exactly how to fix the errors in each of those little pieces. And by doing this over and over again, the student model learns something incredible. It doesn't just learn to avoid making mistakes in the first place. It learns to recognize when it's about to make a mistake, and then how to correct its own course, right in the middle of generating. It literally learns how to recover from its own errors.
Okay. So let's get to the results. Because this new training method didn't just push the boundaries a little bit, it absolutely shattered them. From a 5-second wall to this, the model trained with self-forcing ++ was able to create a coherent, high-quality video that ran for over 4 minutes. I mean, think about that. That's not just a small improvement, it's a 50 times leap forward. Insane.
And it's not just about making videos longer. When you actually look at the numbers, self-forcing ++ just crushes the older methods on quality. Visual stability, that's basically asking, does the video stay clear and not fall apart? And dynamic degree asks, does it keep moving naturally? On both of those, it's just a massive win.
I mean, just look at this chart for visual stability. The score literally jumps from the low 30s for the other models all the way up to over 84. What this really shows is that the AI isn't just making longer videos, it's making them without the quality completely degrading into that blurry, washed-out mess we saw earlier. And what might be the most amazing part of all this is how they did it. The researchers didn't have to go out and find some giant new dataset of minute-long videos to train the AI on. Nope, they just taught the model a much smarter way to learn from its own mistakes. It's about working smarter, not harder.
So why does any of this matter, really? What does breaking this time barrier for AI video actually mean for all of us for the future? Well, what's so powerful here is how it completely reframes the problem. Instead of trying to build an AI that never makes a mistake, which is basically impossible, it teaches the AI how to learn from them. It's such an elegant solution that doesn't just improve the old way of doing things, it opens up a whole new world of possibilities for what these models can do.
This breakthrough really signals a major shift. We're moving away from seeing AI as just a generator of short, kind of gimmicky viral clips, and toward AI becoming a real, legitimate tool for storytelling, for making educational content, short films, you name it.
And that leaves us with a pretty fascinating question, doesn't it? For the very first time, it's actually possible to generate a compelling, minute-long story from just a sentence of text. The only limit now is really our own imagination. So, what stories are we going to ask it to tell?